Let's talk about the electric circuit, and in particular voltage, current and resistance. Voltage is the electrical pressure between 2 points, and it's measured in volts. I like to think of it as a horse race where all the horses are at the gate and they're ready to go. So imagine that at the power point. So all your power points is electric. There's a voltage right there at the power point. If you've got a multimeter or a volt stick, it'll start going, it's singing as it gets close to the power point because the voltage and electrons are ready to go. They're like the horse, ready to go when the siren or bell goes. A voltage always exists between 2 points that have a different number of electrons. Current is the actual flow of electrons along a conductor, such as copper wire, from a high point of energy to a low point of energy. And it's the current that creates the AC magnetic field. For current to flow, voltage has to be present. So when you are measuring AC magnetic fields, you know that there's going to be voltage present. The thing is with measuring voltage is that it's always, because it's 240 volt used in our building wiring here in Australia, that the electric field that's emitted from the voltage will always be around 1.2 meters. Whereas the current, the AC magnetic field emitted as a result of the flow of electrons will vary depending on the current, the actual amount of electrons that are flowing through that conductor. It is measured, the magnetic fields is measured in amperes. Resistance is opposition to current flow and it's measured in ohms. A conductor like metal has low resistance because the electrons can flow very simply and because the metals are giving up their electrons in the outer orbits. An insulator like glass or plastic, however, has high resistance. It doesn't enable the electrons to flow from one of its atoms to the next. The higher the resistance, the less the current. So resistance is likened to a flow restrictor in the shower head. Ways of restricting the flow of water through the shower head would be by installing a thinner pipe, installing a much longer length of pipe, or using a pipe with really rough internal walls that increase the resistance to the water flowing. And electricity is very much like that. Electrical resistance depends on the diameter of the wire. The thicker the diameter, the easier the electrons flow. The length of the conductor and the material of the conductor. And that's often why copper is used, because it gives away its electrons so easily. Lamps offer some restriction to the flow of charge and consequently they emit light and heat. Resistors restrict the current in a circuit, and the symbol we use for a resistor is as follows. So having a look at the electric circuit, we find it consists of various parts. The first is the battery, which is the voltage source. It provides the electrons at the gate. The electrical load would either be a lamp through which the electrons would move through, or a motor such as in a fridge, or a heater, for example. The meter, the ammeter, is actually going to measure the amount of voltage, or multimeter. And of course the wire is the conductor which enables the electrons to flow. So for the circuit diagram, it consists of the various ways. You'll see this is the way it's actually drawn in textbooks to simplify it. You can see the battery is shown by this particular symbol, and then you'll find the lamp will have this symbol, and of course the meter itself will be this symbol here, and the wire will just be a straight line. So this is the way you'll see a circuit diagram in many of the electrical books. The players in an electrical circuit will generally be voltage, current and resistance, which we've just alluded to, and I've already indicated the symbol for voltage is V, the symbol for current is I, and the symbol for resistance is R, and the definition for voltage is electrical potential. The definition for current is the movement of electrons along a conductor, and that's what gives rise to the AC magnetic field. The resistance is anything that resists the flow of the electrons. To measure voltage, we use a multimeter or a volt stick. To measure current, we use a Gauss meter. And to measure resistance, which is something we don't do in building biology, but we would use an ohm meter if we did. And to have a look at the dynamics between voltage and current and resistance, we use what's referred to as Ohm's law. So voltage equals the current, which is the movement of electrons, times by the resistance. And if you think about it logically, it's actually quite logical. Now in maths, we know if you can convert the equation in different ways depending on where the equal signs is. So current equals voltage over resistance, or resistance equals voltage over current, and this is the triangle we use. So in order to consolidate the information about the circuit, refer to these two references. First, watch the video by Bozeman Science on voltage, current and resistance, and then read the chapter on the electric circuit by the Electrical Principles book by Peter Phillips.